Hey guys, a very good morning. This is Ruby and the career counselor at Unicaksha. I will be your host for today. Just allow us some time so that we can just, be expecting few more participants. So just allow us like a couple of minutes time so that we can start. Thank you for being there. Thank you for your patience. Thank you so much for your patience, for waiting for us. I think it's time for us to start the session now. So today's session will be taken by our experienced mentor Swati Yadav, and the topic today would be dynamic challenges. So we'll just start the session right away. You have the Q&A, option here in case if you have any question throughout the session. You can paste it on Q&A session. We will, take it up. Maybe Swati, our mentor, will answer that question, or maybe we will be answering all your questions here. Feel free to put down your question in Q&A. Swati, over to you.
Hi everyone, a very good morning to you guys. So, my name is Swati Yadav. I will be your mentor for your today's session with Unikaksha. And the topic that we'll be covering today is cracking the dynamic programming challenges and entering into MAANG. And not just MAANG, you can target any product-based companies if you have a good hang of dynamic programming. So there is no doubt that, dynamic programming problems can be very intimidating. Yes. And in a coding interview, right? So even when you know that a problem, it needs to be solved using a dynamic programming method, a DP method, it's a challenge to be able to come up with a working solution in a limited time frame. So the best way to be good at dynamic programming problems is to go through as many of them as you can. While you don't necessarily you don't need to memorize the solution to every problem, because there are so many problems out there. Then there are not just the problems, they are not limited, but people can come up with newer problems that as maybe kind of part of your interview process, and just provide you with that. And you have to be good at solving those DP problems and how to implement that as well. So although people make a very big deal about how scary DP problems are, there's really no need to be afraid of them. And in fact, once you get the hang of them, these can be actually very easy problems to solve. So before I start, the agenda of our today's session is to get familiar what is DP, what is dynamic programming, what are the types of dynamic programming available, and the approaches which are there. And apart from this, we are going to take a look at 2 to 3 examples of how we can solve dynamic programming problems. Fine. Now, starting with what is dynamic programming? You might have heard dynamic programming. What do we understand by dynamic programming? So dynamic programming is a technique wherein you try to solve problems by breaking them down into a collection of sub-problems. So there is a bigger problem, you try and break it down into sub-problems and solve each of those sub-problems just once, and storing these solutions inside the cache memory in case the same problem, it occurs the next time. So DP is mainly an optimization, it's an optimization technique over the plain recursion. You might be aware of recursion technique. So whenever we see a recursive solution, that has repeated calls for same input, you can, optimize it using DP. Now, this simple optimization, it reduces the time complexities. We might be aware of the time complexity, and from there you can reduce the time complexity even from exponential to polynomials. So briefly speaking, DP is mostly just a matter of taking any recursive algorithm and finding the overlapping subproblems inside it, that is the repeated calls which are there, right? You then cache those results for future recursive calls. So alternatively, you can study the pattern of the recursive calls and implement something iterative over there. And you still, use cache for that work. So that, just a basic understanding of what DP is, that is that. So, we are into process. You guys must be into process of appearing into interviews these days. And you might be anticipating a job interview with the big tech companies which are there, maybe like MAANG, or some other tech giants. And so you would like to be prepared, because DP rounds are there. These technical rounds, they do come into the play, and these are not just very simple rounds. You get a problem that you have to solve in real time and so on. So in fact, a growing number of firms, they have even started to include technical coding assessments, right, in their interview process for, for data scientists, for FSD developers, machine learning engineers or software engineers. So such assessments that they have over there, it's, they usually test candidates, right, on DB, on data manipulation skills, something like with SQL, their problem solving skills. programming skills with data structures and algorithm, which you guys would be aware of, right? Now, the programming skills with DSA, it often includes DP also, an optimization technique, right? That can produce efficient codes with reduced time or space complexity. A very simple example can be done in many ways. That is what we are aware of if we are into this profession, right? I give you a problem, it can be done in 2 to 3 or 4 even ways. But which is the best solution to go for? That is what we look for, when we work on real projects, because there we have these time complexity, space complexity to keep in mind and work on the project itself. So that is where, it becomes important for us to understand dynamic programming. The next thing is, what are the characteristics of dynamic programming, right? So many of us, we face the difficulty. How do we identify that a given problem, it's a dynamic programming problem or just a normal programming? Yeah. So how do we know that you can solve a problem with this dynamic programming approach? So there are a few questions which you can ask, based on if you want to characterize any question, any problem, whether it's a dynamic programming problem or not, and those questions are, the first question which comes up is, can you break down the problem into some smaller or into sub problems? So if there is a problem at hand, can it be broken down into sub problems? That is the first question which we ask. The second which comes is, are there any overlapping, sub problems, any other overlapping sub problems here in the statement itself? If there are any other, overlapping sub problems, then what we do, we solve the sub problems, the smaller sub problems optimally over there, using the optimization techniques, and then use them to construct the optimal solution to solve the main problem. So while solving the problem itself, does the decision on the current step, it affects the outcome and decision of subsequent steps. So if the answer to all the questions, is yes, that means you can apply dynamic programming to solve the, that particular problem over there, So there are a few questions which I've just told you, that can it be broken down into sub problems? Any overlapping sub problems in there? If there are overlapping sub problems, can you, solve those optimally? If you can solve those optimally, then that means you solve them optimally and then you combine them to construct the main solution. And when you solve the problem, does the decision on the current step, whatever you're taking, that affects the outcome and the decision on the subsequent or the steps that will come in. Okay. So that these are the questions which you need to ask to identify any problem, whether it falls into DP or not. So there are 2 key attributes, that a problem must have in order for dynamic programming. 2 key attributes. And those are, there should be an optimal substructure. Let me open up. Moving you guys to the whiteboard. Okay. So I said that, there are 2 key attributes, and what are those? Optimal substructure, and another is overlapping subproblems. Okay. So you do not confuse dynamic programming, the problems with divide and conquer, because this might sound similar to you, in divide and conquer also we do the same thing. We divide the problem into smaller parts, we solve them and we put them together again, right? Something like that. or with a greedy algorithm that we have. Those are two different things. Okay. With divide and conquer, it also solves a problem by combining the optimal solutions from subproblems. However, they are non-overlapping in divide and conquer. Okay. Whereas in greedy algorithm, you try to make a greedy choice. So there are two more terms that you might have heard. Divide and conquer and greedy algorithm, right? So these are different, these are different from DP. These are different. In divide and conquer, there are sub-problems. There is an optimal solution which is involved, but there is no overlapping. In greedy algorithm, what you do is you make a greedy choice, to provide a locally optimal solution for each step. And this may not guarantee, that the final solution will be optimal or not. So you're not sure about that. So greedy algorithm would never look back and it's not going to reconsider its choices, while DP may revise the steps, based on the decisions. It might come back or, to the previous step and try to work with that. So that is the difference in divide and conquer, greedy and DP. So these three are different. Don't confuse them. Now the next thing is types of dynamic programming questions that do come in. Okay, there are different types of questions which come in. Like, what do they look like? Okay, so let's see some of the most common types of programming questions. The first type which comes is, of dynamic programming question, which is also the frequently encountered kind. You get this on a frequent basis, is to find an optimal solution where you try and find the optimal solution, okay, for any given problem. Example, we could be asking you to find the maximum profit, the minimum cost, maybe the shortest path, you might have heard, the longest common subsequence, common subsequence. So that is the example, where we try to give or you to try to find an optimal solution for any given problem. The second type which comes in for DP programming question is to find the possibility, of achieving a certain outcome. Let's say the possibility of reaching a certain point, a possibility of completing a task, the possibility questions which are there. Okay. So the second type is to find the possibility of achieving a certain outcome. So this is the second kind which comes in, within specified condition, there would be that, you need to complete a task and the question would be like that. And there would be a certain questions. The third kind is referred to as the counting problems that you get, or, another word for it is combinatorial problems, or you could say counting. Okay, in the form of like you get a matrix, somewhere where you to find the number of ways to perform any or accomplish a task, something like that. And note that all the three of the DP programming questions that you might get could also appear in any 2D format. You might get a matrix as well. So more complex problems involve multiple dimensions. Simple one won't be having much of dimensions over there, but it's a complex problem. It'll be like multiple dimensions, So these kinds of questions, they do come in your DP. So there are approaches as well. And what are the approaches? Let's talk about that. Approaches to implement dynamic programming. So you can solve dynamic programming with the bottom up, or a top-down approach. Regardless of which. So it's regardless of which we need to define and come out with the base case of the problem. So generally the top-down, it starts by looking at the big picture. So for top-down, you look at a big picture, the whole problem at hand. And from the high level, it gradually drills down into the solution, from smaller sub-problems. And finally, the base case for constructing the solution. As opposed to the top-down approach, the bottom-up approach, it starts from small, by first looking at the base case. So in bottom-up, you first look at the base case. In both of them, the base case is involved. Only difference is top-down. That's the last thing, for constructing the solution. And bottom-up, the first thing to consider is to look at a base case. And from there, step by step, we build up the solution to the bigger sub-problem. So before solving the entire problem or entire, solution as a whole. So let me give you any kind of example for top down, so imagine that you want to make a delicious, like, something like a gorgeous looking birthday cake. There are birthdays coming, in my family. So I can't think of anything else right now. So now if I want to bake a, delicious kind of, something which is out of the ordinary, someone might have not thought about it, kind of like that cake. And how to achieve that, I'm no baker. I don't know how to do that. So I can make use of maybe like some cream, that there can be like compote, flowers. I can even put some strawberries on it to decorate the cake and so on. So how to prepare all of these things? I need to whip up, right? I need to prepare heavy cream, maybe with, put sugar into it, have strawberries, to cut them down, to cook the berry compote if I need to put it into the cake. But where's the cake? That's the decoration part. I do not have the cake right now, right? I need to prepare the cake again. So for that, I need to prepare the batter, bake the cake. And then, maybe like put some sugar into it, milk into it, flour and milk and everything, right? So how much to use for each ingredient, then I have to measure that. So that is a top-down approach. You know that this is what you need to do. You start working on that one by one. Now, bottom-up will be you start measuring things first. How much you need, what do you want, and prepare the cake ingredients. So with all the ingredients ready, first you have the ingredients in bottom up. So first you have all the ingredients. Then you start maybe making the cake mix, next you put it into the oven and you bake it for, let's say, 45 minutes. And after baking the cake, you let it to cool down, and then you cook the berries, you cut the strawberries, and whip some cream to go for that. You put the cream on it, and thereafter you frost the cake, right? With the frosting, you spread the berry compote that you made, and you put some strawberries and you arrange it with flowers. And that is the bottom-up approach, in which you started from small and then you had the whole picture, right? So now can you notice how the bottom-up approach does things in an orderly fashion, from the basic. Bottom-up had like some order, it was maintaining an order, but in top-down there was no such order which was there, right? Means I was starting from anywhere. That was the thing. Now, in top-down approach, the implementation of top-down approach, it uses with it recursion and memoization. Two things. So it uses recursion with memoization. I'm so sorry. Written and with memoization. Now, what is memoization? So memoization is the technique of storing the results of calculation so that they can be retrieved and used directly when the program, it requires them again. So this is especially useful for overlapping sub problems, as it helps to avoid the same calculations twice, thus improving efficiency and saving the compute time. So here, for memoization, what is commonly used is hash map and arrays. Okay. And this approach, it will make recursive function calls as per the recurrence relation that we define. So as long as the current state is not the base case, right? Now in bottom up, in your bottom up approach, what we have is to implement, we need to, iterate. So there is an iteration which is involved. You need to iterate over all the states of the problem in a specified order, where you start from the base case. There is a base case and you start from the base case. Okay. So by doing so, you build up the solution step by step from small to big, and such that the answer for the current step can be easily computed using the available sub-problem solution, which was computed from the earlier sub-steps. So this process, it keeps going until we build up the entire solution. So the bottom-up approach is also known as another name for it is tabulation method. Okay, since this approach, it goes, you could say, tabulation, because since this approach, it would go through each step in specific order, and it performs computation. It is easy to tabulate the results, in an array or list. So where they can be conveniently retrieved by the relevant index for use in subsequent steps. So for some scenarios, tabulation can be avoided to space, save, and memory. Okay. So which approach to use and which is preferred? That is also one question that might come to your mind, if you have two approaches. So it's generally fine to use either of the approach. Either you go for top down or you go for bottom up. So after all, DP is not easy to comprehend again, so you can use whichever approach that comes more naturally to you. What do you think? You're good with making base cases first and starting with the bottom up. You implement that. If you think top down is something that you can do the memoization, you do that. So whichever comes naturally to you, you work with them, and the one you're more comfortable with. So while some may find it easier to frame a solution with recurrence relation and code with the top-down solution, the bottom-up iterative process, could sometimes execute faster, and, it might come handy to some others. So most of the time, the difference between the two, it's just marginal, So if you're skillful enough and able to code both, needless to say, go for that one that has less time and space complexity. And means if you're trying, if you've mastered both of them. So that is something that you can, always make a choice of working with. Now you have a few questions coming up your way. Okay. So let's take a few poll before we move on to the next thing.
Well, we will just have a quick attention check here. Let's see, we have a good amount of people, have attended the session. Let's see how much are you able to follow what Swati is, explaining you. So the poll is right in front of you, wherein the question is memoization is used in which type of dynamic programming approach? And you have 4 options right here, which is top down, bottom down, recursion, and last one is none of the above. Guys, this poll will actually let us know if you're following and you're attentive about this session today. So we look forward a lot of correct replies here. The poll is just gonna end in 2 seconds. So kindly go ahead and key down your answers here. Meanwhile, also, if you have any questions in regards to the session, we have our expert here who can answer it. Do mention that in the Q&A session. Thank you so much for answering this question. We will move ahead now. Swati, over to you.
Okay, so I saw that a great deal of you have, the right answer. It was top down, memoization. So it's recursion with memoization. So the answer, it came under the umbrella of top down. Okay, so now I'll start with a few of the examples, that I thought of maybe discussing with you guys. So for this, I'll start writing. Let me check. Okay. So there are a few examples, and let's go in a good amount of detail right now for the following examples, like climbing stairs, robbing the house. So these are the, questions. These are kind of, problems that come into the, interviews that you might have to solve. So I just wanted to okay, so I just wanted to take up a few examples for us to work on. So let's start with climbing stairs. So it's an easy to understand problem. Just give me. It's an easy to understand problem. Okay. So in this problem, we are given a staircase. There would be a staircase that would allow us to take, steps on it. Like it could be n steps, it could be n plus one based on, the problem statement itself. And to reach the top, from bottom to top. And each time we are only allowed to climb one step or two steps. Okay. So it would be something like a staircase that we can have. And, you might be over here. Don't go on my, drawing skills. This is the top where you want to come up. Okay. So let us begin by thinking of a base case over here. So if we were to get to the first step, if you had to go to the first step over here, in how many ways can you do that? If you have to go to the next step, climb up the next step, in how many ways can we do that? Just write it down in chat or Q&A. It's open for all of you. One, very nice. Yes, it is just one way, right? So there is only one way, and that is to climb one step. How about getting to the second step? Now, let's say you directly want to go to the, maybe you want to go to the next step, which is there. How would you do that? Two ways. Very good. So there are two ways to do that. So two ways in that either you can take one step at a time, means you go to first step, then you go to the second one, or you can directly, climb up, or you can climb two steps at once. There are two ways to go. The second. Good. So getting to the first step and getting to the second step, it constitutes the base case for this problem, right? Do you see the base case which has come up? So now how about the third step, the fourth step, and so on? So if you have to go to the third step, just see, you can either go one step or two steps at a time. Okay? So for the third step, there can be three possible ways again. But again, the three possible ways, either you climb one step for 3 times, or you climb one step followed by 2 steps, or you climb 2 steps followed by 1 step. Yes or no? So that means either you can go 1, 2, 3, or you go 1 and you directly jump on 3, or you jump on 2 and then you go on 3. So there are 3 ways. And how do we get this number? We are just adding the result from the first step, right? We are just adding the result from the first step and the second step, like from the first step and the second step, which is 3. So this tells us that from the base case, we can construct solutions to other steps, right? Assuming, let's say there is a function called as stair climb. Okay? And this is a function that returns a number of ways to reach the step n. So there is the step which you want to reach. Let's say it's the 6th step. Any number. N can be any number over here. Fine. So then what will happen is stair climb n will be equal to stair climb n minus 1 plus stair climb n minus 2, right? And there you have it. It's the recurrence relation. This is the recurrence relation. Recursion, right? So this is the recurrence relation for this climbing stairs problem. So the current step, it takes the computations, from the previous 2 steps, and then it sums them up. Okay. So it goes something like that. So let's say you want to climb 6th step. So it would be 5 plus 4. That means not 5 plus 4. This is for the function that you are applying. Okay. This is the n which I am giving. Fine. This is n again. Or if you want to go stair climb, let's say 5, it would be stair climb 4 plus stair climb 3, like that. Then again do for all the cases, and you'll come down to 1. Now to get the result of climb 6, to get the result of stair climb 6, we need to compute what we have to compute. We have to compute 2 things. We have to compute stair climb 5 and 4. Right? To get to the result of 5, you need to compute 4. Then you need to compute 3 and so on. So you can clearly see here that in order to, climb for 6th step, you have to compute 4. You have to compute 3, right? Again, you have to compute 2 and 1. So that will result into a time complexity of O to N. Okay? Raised to the power n, sorry. And now here with memoization, if you do the same thing, you can get away with the redundant computation. Now to show this, let me show you the chart or the tree which comes up for this kind of problem, where the overlapping subproblems is having without the memoization technique. Okay? So without the memoization technique, if we are climbing 6, okay? So if you have to climb 6, that means you have to compute 5 here. You have to compute 4, right? Now for 5, what you need is you need 4 and you also need 3 to be computed. Yes? For 4, what do you need? You need 3 to be computed and you need 2. Okay? For 3, you need 2 and you need 1. Okay? Then again for this, the same thing goes for 3, you need 2 and this would be 1. For 4, Now you take a look how many times I'm computing the functions. Climb 3, climb 2, again the same thing, climb 1, climb 2. So I'm computing 4 2 times, 3 again 3 times. So that is the redundancy what I'm getting. That's why the complexity which I'll get for this is this, raised to the power n. Now this was without memoization. Now with memoization, you can get away with the redundant computations and just retrieve the previously stored result. That means you have that result stored in cache and then you can retrieve that. So let's say for 6, compute 4, it's computed, compute 5. So 4 is already computed, you don't need to compute it, compute 3. 3 here, when you have computed 4, that means for that you need 3. That is also computed, it's done. So you don't need to compute it again, compute 2 and then 1. So that is how you work with memoization, okay? Now with memoization, it reduces to ON only because you are computing it only once. So we have the base case and the recurrence relation. Now the time is to write the implementation, for memoization. That would be using the top-down approach. So for memoization, we basically use a hash map, to store the results of computation. So if result for, n, it exists, we skip the computation and retrieve the results from the hash map itself. Okay. Both the time and space complexity for this approach is ON. This is because you are literally going through every step. And for each step, you're storing the computation result in the hash map itself. Fine. So that is how you do it. So if you are doing top down, there we'll be using hash maps for storing the result. Let me show you a very simple implementation. So let's say I'm creating a hash map. Let's say result. This is a hash map for memoization. I am creating a method, for computing everything over here. The base cases I'm going to write. Just don't worry about that. Def climb n. So this is in Python. I'll write it again on an IDE, don't worry. Now the base case over here will go as, what will be the base case? So there can be 2 base cases. If n is equals to 1, what you need to return? You need to return 1 for that. That's the base case. That means number of ways to get to the first step. The second is if n is equals to 2, then you need to return 2. That means number of ways to get to the second step, that is 2. Okay. Now comes the next part. So if n is greater than 2 and is not in the hash map, okay, if n is not in the hash map and it is greater than 2, then you have to perform the calculation and store the result in the hash map. That is what you have to do. Else you need to skip computation and retrieve the results from the hash map itself. Fine. So it's again very simple. If n not in result, this is your hash map. Okay, if it is a hash map, then result n equals to, what you need to do is a recursion. You have to apply recursion. Climb n minus 1 plus climb n minus 2. This is the recurrence relation over here. And then you simply just return result of n like that. Just this is the whole solution for it. Okay. This is the whole solution that you've performed. Now the test case is you're just returning, you print. Climb, you give any number over here, let's say for 13, and you'll get the answer. That means how many steps are required to reach this 13. Means how many ways you can go. Now that is one thing. You can also have a bottom-up approach for the same problem. So you can use an array to tabulate the computed values for each step. However, for this problem, since the current state, it depends only on the previous two states. Yeah, you can efficiently just use two variables over here for for bottom up approach, I'm saying. And that would be, you can have two cases, case 1 and case 2, to keep track of them while iterating for the for loop. Okay. So again, the bottom up approach would look like something. And that would be, you have like a function, climb. There are two things, that the base case which you check. If n equals to 1, return 1. If n equals to 2, return 2. These are the base case. Now you store it into a variable. You store it into case 1 and case 2. 1 and 2. Okay, so number of ways to get to the first step is 1, and for second it's 2. Now, if the staircase, it has more than 2 steps, that is n is greater than 2, you have to iterate from the third step onward then. Okay, so for iteration, you will be using for loop over here. For in range, you give any range, that means it should be greater than 2. Okay, until n, whatever number you're putting, you calculate the result here itself, case 1 and case 2. That means then case 1 barabar case 2. That means you're replacing case 1 with case 2. You are computing the ways to get to the current step. You're replacing case 1 with case 2, and then you are again assigning case 2 with the current computation. Okay. Case 2 with the result itself. So that's it. That is how you do bottom up for this problem. And then you return the result. So this is climbing stairs, which you've done. The next type of problem is, or the next kind, you might have heard of it or not, that it's also robbing a house. And a different problem. This is another classic problem of dynamic programming, robbing a house or house robber, kind of like those you might hear. And in this problem, you will be given an array of integers, that will represent the amount of money in each house. These are simple problems. The statements might confuse people, but these are very simple problems, just an array questions that you need to get a hold of. So the problem, it states that you are given an array of integer. Let's say you have a few array. This is an array of integers, and each number that will be inside it, amount, it represents money in each house that is there. The houses, they are lined up on a street. There is one constraint though, that the robber cannot rob the adjacent house. So if he has robbed the first one, cannot do the second, to go on to the third and so on. Okay, so for example, if the houses are indexed, 0, 1, 2, 3, 4, right? So he can rob house 0, 2, 4, or he can rob 1, 3, kind of like that. Okay. So that is the only constraint. So let's say you have 10, 60, 80, 20, 3, something like that, So now he need to rob the houses. Now, what is the maximum amount of money that the robber can rob from the houses? That you need to determine here. This is again another kind of dynamic problem. When I told you the types of dynamic problem, the maximum amount of money that the robber can rob, So the sample would look something like an array. Let's say you have an array, it would have 10, 60, 80, 23, kind of like this. Yes. So we start by thinking about the base case, and there is only one house in the base case. That would be house 0 for the base case. What would you do? You just rob that, take the money from the first house. That is the only house, and this is because there is no other choice to consider. Suppose you have two houses. You have house 0, the first one, and the second one. Now, which one do you rob? You cannot rob both of them since they are adjacent to each other. You can either rob 0 or the one, the index one. Okay. So, well, of course, you will rob the house containing more money. And to find the house containing more money, you can apply the something, an aggregate function over here like max. You can try to find maximum number, in which do you have. So, like you can do max house 0 and house 1. Okay. So notice how this, it forms a base case for this problem. Now that if there are many houses, what do you do then? Means now there are 3 and more houses. Now what do we do? So let's say you are at house 9 or, any house n. So you have two options. You whether to rob or not to rob the house. The first thing is for any house, you either rob or you do not rob. Okay. Now let's say there are many houses. 1, 2, 3, 4, 5, 6, 7, 8, 9, let's say. From 0 to 8. Okay. And 1, 2, 3, 4, 5, 6, 7. Okay. So let's say you are at this particular house. If you decide to rob the last house, then what we would get is the amount of money, what would be the amount of money from there, and plus whatever the amount that you got from the previous houses if you robbed the previous houses. So if you decide not to rob, then what we have is simply the amount you got from robbing the previous houses. That means up to that house. Okay. So that is something like 2 to 3 things that you need to take in mind. So rob house, a method maybe, and you're trying to rob an n house. So if you're trying to rob an nth house, here what will you have is the amount that you've got up to the 2 houses before, from coming to that particular house. Means you've reached this house, but you kind of robbed many houses still here. Now you are deciding whether you want to rob this house or not. That is 2 choices that you have. Okay. So in the first cases where you robs the house, where you decide to rob the house, there, what is the maximum amount you will get? You rob the house till n minus 2, then n, and then you rob the house n minus 1. So this is still where you decide to rob the house. And this is when you decide that you don't want to rob the house, you only end up till before. Okay. So there are 2 things that you've combined together. This whole is where you rob the last house as well, this nth house. That means whatever you've robbed so far plus that house that you've robbed, that is the maximum amount you're getting. And the last one, this plus rob house n minus 1, is when you don't decide, when you decide that you do not want to rob that house. Now to find out which option yields the maximum amount of money, you apply the max function for that. So whatever is the maximum, you take that. And this makes your recurrence relation. Okay. Now with the base case and recurrence relation on your hand, you can now write the solution using the top-down approach. And the time-space complexity for this approach will be O(n) again. Okay. This is again simple. You use hash map for memoization. I'm using Python here, so you can use hash map for memoization. And the base cases would be if n is 0. N is 0 means it's the first house. giving you the base cases. The first is if n is 0, that means you return the first house itself. Or the next one would be if n is 1, then you return which one to, means there are 2. Okay, so which one to rob. So in whichever, the maximum amount will be there, that will be robbed. Because the robber is very mindful. He wants to have more money. So you rob that. Right. Now the next is when there are more, you retrieve results from the hash map if it exists, and else calculates and store it in itself. So this is a top down. So if n is not in the result, then what you do, you go for the whole recurrence relation. Okay. And then you return the answer. So this is how robbing the house it works. So I've come to pretty close to the end of my lecture for today. For your practice purpose, this is the top down that I've given you. I want to assign something. If you guys want to try, I want to assign you another problem. So the same problem, but with a bottom up approach. I would like you guys to practice the same thing with a bottom up approach as well. Let's try and think, how will you try and, work with it? The another kind of problem, another problem which I would like you guys to work with would be the simple there is another problem, if you've heard, is of Fibonacci numbers, so this is a very simple problem statements that you'll understand. It's Fibonacci numbers, and these numbers are in the integer sequence of 0, 1, 1, 2, 3, 5, 8, 13, 21, then you get 34, and so on. So in mathematical terms, if you talk about the sequence of Fibonacci number is defined by the recurrence relation, which is f n equals to f n minus 1 plus f n minus 2. This is the recurrence. The seed values which you can say that you have for here is f0 equals to 0 and f1 is 1. So now if you have to work with this, without DP, it will be a very long process. Without DP, I'm talking about. And I want you to work with this one. This is kind of what I'm assigning you guys after this session to work on Fibonacci, and with the help of memorization. You might have done Fibonacci. It's a very, basic question which we get in programming. So you have to code for this problem using memorization, the top-down approach. Think the base cases are simple. If n is 0, n is 1, then you have to return n itself. Then what to do next, and so on. Well, I've written most of it over here for you guys. You just have to think how you're going to put it into the problem itself. So that sums up my class for today for you guys. So what's next for you is to practice. The more you practice on DP problems, the more you'll be able to grab those. You see, we've done 2 problems, and you've seen that how easy were they. If someone might give you these problems out of the blue, then you think, oh God, this question is so long, how to even start with that. But if you try and think about with the calm mind, you will be able to understand the problem itself, and you will be able to provide the solution as well. So the first thing is to have a cool mind whenever you're appearing for any interview. I know we get those jitters every time. I still do get if I have to sit in any interview. That is one part. But the more you practice, the more confident you'll be to appear in those. And DP is something that you'll have to do lifelong. Because as being programmers, software developers, it doesn't just leave you, it's not just for entering into a company, it stays with you. You have to work on that every now and then. That's the basic thing that you have to get that in your head, is because times complexity, space complexity, making your programs efficient, that is something that you'll be doing each day. So DP doesn't just leave you, so that you might have to hone the skills every now and then. So by all means, go and practice dynamic programming problems as much as you can. And the first step is that if you're not able to crack the solution, fret not. Don't worry, if you get a solution at hand, don't worry if you think that I won't be able to do it. Check out, check out the discussion forum, seek help, start learning. And where, you can usually find some useful tips, someone who can actually make you understand. So the initial phase, you would think that, it's complex. I don't know how to approach around it. But once you get the hang of it, no one can take that away from you, right? So you practice as much as you can. And once the more you practice, the more you learn, and the more you learn, the easier it gets, So that was all about DP session from my end. Now you have a few polls coming up just to check your basic understanding. So Ruby, can we have the polls?
Yes, Swati. Well, as Swati rightly mentioned, when you start learning something new, there's always a guidance that you require. There's always, a mentor that can help you understand things, and especially technical things like these. And that's what our program does. So we basically have programs like full stack development, wherein you will learn all about the front end, the back end, the database under the live mentorship basically. So we have 100% live interactive classes, from these mentors who are IIT alumni and who have actually worked with tier 1, tier 2 companies. And you'll be surprised to know the package that we have provided to a fresher as a full stack developer ranges anywhere between 10 to 12 lakhs. And the highest we've gone up to 21 lakhs. I would want to understand how many of us wants to make a career in full stack development. I'll just run a poll quickly. Let's see how many us, are interested in having a good counseling session with us. So here's the poll. If we get yes and as an answer from you, then somebody from our counseling team, either me or somebody from my team, will get in touch with you. We can have a detailed discussion as to how you can build your career in IT industry, and how you can bag a job of average 10 to 12 lakhs being a fresher. The poll is going to quickly end. Kindly let us know if you want to know more about full stack development program at Unidaksha. Thank you. Well, we still have the Q&A open for you. We'll just wait for another 2 minutes before we end the session. So in case you have any question, we still have Swati here with us, so she can take up that question. So we will give you 2 minutes time to, just think over and come up with a question if you have any. Meanwhile, also, I would want to put across, a few things, that we have multiple programs at Unidaksha, which comes with, multiple payment convenience rather. We have plans wherein you can even pay after placements, wherein we give you 100% job guarantee. So if you are interested in that, you can still put down in Q&A. If you're marked no as in the previous poll, you still can put down in Q&A so that we can get in touch with you. We just wait for another 1 minute to see if you have any questions. Let me just check. Swati, we have a question here, which looks like a very basic question, though. However, if you can just take it up, as in we have a question from somebody who's asking, how will this help to a developer? How will today's topic help to a developer?
Sure. Yeah, hi. So, during the session and while closing the session, I think I made it clear that how this is the everyday work that we have to do, right? As programmers, as developers, when we are planning on a solution, when we are coding for any project for for the organization, whatever we are building, what's the best possible approach to go for, how we can optimize the solution, the whatever project plan that you are working on, the optimization, the space complexity, the time complexity is something that we work on a daily basis. So DP is something that is never is going to leave your side. That is one thing that I can guarantee you guys. That is one thing that you have to take with you working in this profession. And DP is something that is always there, that you have to apply for. You have to look for the best possible solution when you're coding. So there, that is, you have n number of ways to solve a problem. The same climbing stairs can be solved in n number of ways, but what is the best solution? You saw two things. I showed you two examples over there, two ways in which climbing stairs can be solved. One was giving you the complexity of on square, on square, and 2 raised to the power n, I'm so sorry. And the another, the memoization one, it was giving you on. So which one was better? On, right? So this is the work of a developer. So whenever you'll be planning your projects, whenever you'll be working on them, what's the best complexity, what's the best optimization that you can provide? That is what we work for on a daily basis. So it's actually essential for any developer out there to work. So any developer, any software developer, they need to have the understanding of DP.
I hope that answers your question, Raman, because I think Swati had explained it very nicely and in detail as to how this is going to help a developer. And we see that we don't have any more questions coming up. So what we will do is we'll end the session for today, and we'll keep you updated about the next upcoming webinar that we'll have. We'll keep in touch with you. We'll be connected. Also, in case, during that week of until the next webinar, if you want to connect with us, you can visit our website. There's a contact number. Feel free to call us. And we end the session here. Thank you so much for being there on a Saturday morning. I hope this session helped you. Thank you so much. Have a good weekend.